Welcome to Math 1314. This is section 2.5. We're going to look more at lines. First thing we want to talk about is slope. So, to be able to calculate how steep a slope is, whether it's up or down or zero or vertical, I need 2 points. And we just call the points x1, y1, x2, y2. And so, to get the slope, we have m for slope. Why m? I have absolutely no idea. You would think s for slope, but we have m. And so, it's the difference in y's over the difference in x's. It's the rise over the run. If that number calculates to be bigger than 0, it's up. If it's perfectly 0, it's flat. If it's negative, it's down. And if that number turns out to be undefined, then we're looking at a vertical line. In terms of equations of lines, we have a couple of different lines. First one is y equals a number. No variables, just a number. This is a flat line, and its slope is 0. If we have x equals a number, there's no y in it, there's just x and the number, then we're talking about a vertical line, and the slope is undefined. We have something called slope-intercept form, and slope-intercept form, I need to have a slope m and b. B is where the line crosses on the y-axis. Sorry. All right, slope-intercept form. Point slope. To use point slope, I need a point x1, y1. So here's x1, y1, and I need my slope m. All right, so these are the main important equations of lines. Now, if we have two lines and the lines are parallel, so two parallel lines. If two lines are parallel, they have the same slope. If two lines are perpendicular, not just that they cross, but they have to cross in a way that this is a 90-degree angle in there, perfectly perpendicular. So by looking at the lines, you can already see one of them is positive and one of them is negative. And it turns out that the relationship between the two slopes is the product of them has got to be -1. Now, another way of looking at this is to say, well, one of them is the negative reciprocal of the other. Let's see what that means in practice. So here's a table. Supposing we have a line and its slope is 3. Then if I had another line and its slope was 3, they would be parallel. And if I wanted perpendicular, I would need -1/3. You see, 3 times the -1/3 is -1. If we had -4, parallel would be the same, -4. Perpendicular is the negative, so negative of a negative is a positive, and it's the reciprocal. If we had a line with a slope of 2/5, parallel is 2/5. Perpendicular, well, let's see, this is positive, it must be negative, and it's flipped over. If my line had a slope of 0, it's flat, then parallel is going to be flat too. Well, how would I do negative reciprocal for perpendicular? Well, let's see. If this is flat, then the only way to be perpendicular is to be vertical. And so it is undefined. All right, so let's take a look here. In question 1, they say use point slope to write an equation of a line that passes through this point, and this is my x1, y1, and it has a slope of -4. And write it in slope-intercept form. Okay, well, let's see. Here's point slope. The minuses are part of the formula. My points are 2 and -10. Slope was -4. Let's see. Minus a -10 is y plus 10. Here I'm going to distribute the 4, so a -4x plus 8. I'm going to bring the 10 across, and I get 8 minus 10. And so I get y is -4x minus 2. This is in slope-intercept form. Line is going down with a slope of -4. It's crossing on the y-axis at -2. All right, question 2. They want us to write an equation of a line using point slope formula, and it's got to pass through these 2 points. And they want us to put the answer in slope-intercept form. All right, well, I've got my formula point slope, but they didn't tell me what the slope was. How do I get the slope? Oh, that's right. I have a slope formula. So I can use my points to get the slope formula. So let's see. My y's are 2 and 0, 2 and 0. Corresponding x's are 0 and -5. So 2 minus 0, 2. 0 minus a -5 is a +5. So the slope is 2/5. All right, well, x minus 0 is just x. And if I bring this -2 to the right, we get it in slope-intercept form. Slope's going up with a slope of 2/5, crossing on the y-axis at 2. Now, I used 0, 2 as my point up here. It wouldn't have mattered. I could have used -5 and 0, and I would get the same result. So which point you use doesn't matter. The order that you pick x1, y1, and x2, y2 doesn't matter. That matters is you keep the points together. All right, question 3. I want to use point slope to write an equation of a line that passes through -1, 4. Okay, point slope here. Yep. Has a slope of 0. All right. Well, 0 times anything is 0. And bring the 4 over, and I get y is 4. Now, I could have got this already because I knew the slope was 0. Anytime it's a slope of 0, it's y equals a number. And we know it has to go through -1, so -1, and up 4, so that's got to be 4. And so it is y equals 4. All right. Question 4. We want to use point slope again to write an equation of a line that goes through this point and has an undefined slope. All right, so I try to get point slope. I'm filling in my point. What do I fill in for my slope? Do I just write the word undefined? No, that just doesn't work. I can't do that. So point slope is useless. So what do we know? Well, we know that undefined slopes means it's a vertical line and it's of the format x equals a number. Well, if it has to go through the point 1/5, 5/6, that means I went over, and this is 1/5 and then up 5/6. So the equation is x equals 1/5. All right, question 5. They are giving me a slope of 3/5. So what would the parallel one be? Well, parallel would have to have the same slope, and so that's the same number. What about perpendicular? So parallel was first, perpendicular. Well, let's see. It's got to be the negative of this number and the reciprocal. So flip it over. And so I get a minus 5/3. And you can check that the product is -1. All right, question 6. I want to determine if these two lines are parallel, perpendicular, or neither. You might say, well, how can they be neither? Well, they can just be crossing in some way. They don't have to be crossing perpendicular. Well, let's see. The slope of this first line, it's in y equals mx plus b form. So I see m is 8. And I look at the second one's slope, and that's a -1/8. Well, they're not the same, so they're certainly not parallel. But what about the product? Well, the product is -1, so they are perpendicular. Okay, question 7. We want to determine if these two lines are parallel, perpendicular, or neither. But they're in a terrible format. I can't determine anything about the slope. I can only read off the slope if I can get y by itself. So let's see. In the first one, I'm going to move the -6 to the left and the -5y to the right. Now that looks better. And now divide everything by 5. And so I see that m, sitting here in front of the x, is a -4/5. What about the other one? Let's see, how am I going to get y by itself? I'm going to move the 7. Got that. Now I need to get rid of this 5/2. I could divide everything by 5/2, but that looks ugly. So I think I'm just going to multiply by 2/5 because the 5's cancel and so do the 2's. So if I do that, that's 2/5 times a -2x, which is a -4/5 x, and I would get a 14/5. So looking at my second line now, I can see it has a slope of -4/5. And that's the same as the other one. So these two lines are parallel. Question 8. I want to find an equation of a line that'll go through this point. Okay, let's just stop there. I gotta have a line that passes through this point. So I can use point slope to go ahead and fill in my y and my x. All right, I don't know m yet. We haven't read that far in the problem. So I'm just going to leave it there. So what is this m? Well, our line is supposed to be perpendicular to this other line. Okay, so our line has got to be perpendicular to the other item. So looking at this other item, what is its slope? Well, I can't read it. It's in a bad form. So let's see. I'm going to move the 1, move the 5y. That looks better. Divide everything by 5. Okay. 5's cancel. X over 5 is the same as 1/5 x. So our line, the new one, has got to be perpendicular to this one, and this one has a slope of 1/5. So ours that's perpendicular is the negative reciprocal, or -5. And again, you can check that the product of the two is -1. All right, so we put our -5 in now. I can distribute it. So -5x minus 20. Bring the 4 over. -20 and 4 is -16. And so this is in slope-intercept form. It's a line going down, crossing on the y-axis at -16. Now they also wanted it in something called standard form. Standard form is fairly useless to read off any information, but it's a pretty form. So we put all the x's together on one side, leave the number on the right. So in our case, all I have to do is move this -5x to the left, and I get 5x plus y is -16. All right, so in question 9, I want to write an equation of a line that passes through this point and is parallel to the y-axis. Well, let's see. All these lines in red are parallel to the y-axis, and they're all vertical lines, which means they're all of the form x equals a number. But let's see. Our line is supposed to go through over 3 up 11, so this is crossing at 3, and I get x equals 3. And finally, in question 10, we want to find an equation of a line that passes through this point and is perpendicular to the x-axis. How do I make something perpendicular to the x-axis? Well, it's got to go up and down. And if it's up and down, it's perpendicular. If it's up and down, it's a vertical line of the form x equals a number. Well, what number? Well, we have to go through -8/11, -3/13. Well, the x place is -8/11. And that's our equation of a line that is perpendicular to the x-axis and goes through the point that it is supposed to.